Hello and welcome to today's lesson, working with some special right triangles and using circles and finding Pythagorean Theorem relationships for these values. Okay, so you're going to see some problems very similar to this in the homework. We want to be able to combine some skills that we have working with right triangles and working with circles. Okay, so if you look at our first situation here, we have a 30, 60, 90 triangle cut into this situation. Okay, so we know that that's 60 degrees. And what we have to do is find the area of the shaded region. Okay, so now, in order to find the area of the region of a circle, we have to work through our 30, 60, 90 triangle to be able to find our radius, which in this case is the short leg. We have the long leg, 10 square root of 3. So what we want to do in this case is always remember and work off of our reference triangle for a 30, 60, 90 to be able to find our radius value. Okay, so we have long leg, 10 square root of 3, over short leg, which is the radius, equals, and then we go over to our reference triangle, long leg of square root of 3 over 1. Okay, now we can cross multiply. We've got r square root of 3 equals 10 square root of 3. Since they both have a square root of 3, we can divide that off, and we find out in this case that the radius is 10. Okay, now we're going to use equal proportions as well to find the area of the shaded region here. Okay, so now we know that this white shaded region is 60, so the area or the degrees of what we're looking for is 300 over the total circle, which is 360, and that is going to equal the total area, 10 squared pi, over our desired region, x. Okay, so now what we want to do is cross multiply and solve. So we've got 300 times 100 pi, and I'm going to use the pi like we will type it in Schoology. I'll convert back and forth through there. And then we have equals 360x. So now if we want to get x by itself, we can multiply these two together, divide both sides by 360, and this is where we will end up bringing in the calculator to help us finish this up. 300 times 100, enter, divided by 360 equals, now we've got 83.33. Okay, we don't want to use that decimal value, so in our calculator we can go to math fraction, enter, and then we can turn that back into a fractional answer. 250 pi over 3. Okay, and then we could type the answer in that way. I know the answers also are allowed to be typed in, using the decimal value approximation as well, but if we can keep it perfect, we definitely would like to do that. Okay, now example B, we need to find the area of this circle. So we have to look and see what information we're given. We're given that AB equals 9, BC equals 12. Well, to find the area of a circle, we need our radius value r. Okay, radius isn't something that we're going to be able to solve for here. So what we're going to do is we're going to find the diameter, which is the hypotenuse of this right triangle that we're going to work off of. So now we have to go back to the Pythagorean theorem. This isn't even a special right triangle where we can use ratios, but we're going to use Pythagorean theorem. 9 squared plus 12 squared equals c squared. Okay, c is our hypotenuse value. So we've got 81 plus 144 equals c squared. Okay, we put these together. We've got 225 equals c squared. And then we square root both sides to find that full value. Okay, c equals 15. Okay, and that is this would be one of our special 3, 4, 5 triangles, if you happen to notice that. Okay, now, once we have that value of 15, okay, that is our diameter. So our radius is 7.5. And then to find the area of this triangle, okay, pi times radius squared to finish that up. Okay, so it's not a perfect value here, but we will use the 7.5 squared. Enter to finish it up. So we would have 56.25 pi for our area of this circle. Okay, next situation we're looking at here. Okay, we're trying to find the area of the shaded region. Okay, based on the fact that we've got a circle for our large piece, we've got a triangle for the small piece. So to find the area of our shaded region, we have to find the area of the circle, and then we need to take away the area of the triangle. So we have to think about the measurements that we need. Okay, the measurements that we need for both. Okay, we need the base of the triangle, okay, which we're given here. Okay, we're given the base of this triangle, AB is 10. And now we also need the height of the triangle. Okay, and in this case, the height of the triangle is the radius of the circle. If we notice, we've got a diameter of 10. Okay, so we have a radius of 5. Okay, so now we have the pieces that we need. We didn't have to use any special triangles here. We could use the idea of the circle and the radius to help us solve this one here. Area of our circle is pi r squared, so radius 5 squared pi. Okay, area of our triangle, 1/2 base times height, 1/2 10 times 5. Lost track there for a second. Okay, now what we have to remember is in this situation, since this is a pi value, it cannot be combined with the other. So anytime you're dealing with a circle, your answer should have pi as a part of it. So we have 25 pi minus 1/2 of 10 is 5. 5 times 5 is 25. So we would want to keep that separate. Or if you're told that you could enter it as a decimal value, then you could use 3.14 for pi to plug in and solve that problem. Okay, now, a couple other problems that we want to finish up with in this situation here. A 6-meter wide circular track is shown below. Okay, now, the width of the track is important. Okay, it gives us this distance here. Okay, the radius of the inner circle is 20 meters. Okay, so we have that value there. Okay, what is the longest straight path that you can stay on for the track? Okay, so in this situation, what we're looking for here is we're looking for this distance right here. And what we need to do is we need to be able to build a triangle that we have here. Okay, and in this triangle, what we would want to work with is the fact that we've got 26, 26, 26. Okay, so we have those values there. And then what we're trying to find is the distance all the way across. Okay, so now in this situation, okay, we're not given any degree measures. Okay, we have to assume that when we're working with this situation, we have a right triangle. And to solve this problem, we would just use Pythagorean Theorem and what we want to look at in this situation. And, just kind of popped out at me in the end here is, since we don't know whether or not we have a right triangle up here, what we do know is we have right triangles down here. Okay, so we have 20, 26, and then we're trying to solve for that missing length of the right triangle in that situation. So we're going to have 20 squared, okay, plus b squared equals 26 squared, and then we're going to work through and solve for b. So I'm going to jump to the calculator here to use this for our calculations. We've got 26 squared minus 20 squared. So our b squared value is 276. Okay, we square root that. Okay, so second square root that answer. And we get 16.61 for b. And to get the full distance all the way across, we need 2b for that answer. Okay, so we will multiply by 2 to get our answer of 33.23 or 22. And this would be in meters for our unit. Okay, so definitely a tough one there. You have to think about what type of triangle you can build. Where is the right angle? Okay, we couldn't assume a right angle up here, so we had to look for a right angle down below. Okay, now, one of the toughest ones we have right here. Okay, so we have basically a kite or a two triangle situation. Okay, so when we're looking at this, we need to find the area of the kite, or our two triangle situation, and then we need to subtract the area of the sector of the circle. Okay, so it's not a full area, but it's a sector area. And remember, that area, since it's part of a circle, needs to have a pi value involved. Okay, so now, first, how can we find the area of this kite? Okay, we are given one of the values, 10 square root 3. So what I want to do is I want to take this 120 and cut it in half. Okay, we have tangent values, so we know since it's a tangent, we've got a right triangle, 60, 30. Okay, so we're going to want to build our reference triangle, because what we really need to do is we need to find that radius value. It's going to help us with the area of the kite, which is actually just two triangles put together. And it will also help us with our proportional area of the circle. So now, when we're looking at this situation for the area of the kite, we have to set up and solve for our radius. So we have our long leg, 10 square root of 3, over our short leg, which is r. Okay, remember, we're always going off of our reference triangle. Square root of 3, 1, 2. Okay, so r is equal to the short leg of 1. Okay, our long leg is the square root of 3. And then we can cross multiply Now, if you're noticing some of the shortcut patterns, that's fantastic, okay, but we don't always want to assume the shortcut patterns, as we're going through and working on this material. So now, we have the radius value, which is important because that's also the height of one of our triangles that makes up our kite. So for our kite, it's 2 times the single triangle. So we can see the 2 times 1/2 is going to cancel each other out. Okay, times the base of our triangle times the height of our triangle. Okay, so we can see the 2 and the 1/2 are going to multiply to equal 1. We've got 10 times 10, so we've got 100 square root of 3 is the area of the 2 triangles. Okay, so we have that value. Now what we need to do next is subtract the area of the proportion of the circle. Okay, so once again, we want to set up and do some ratio work here. Okay, we're working with 120 over 360, or 1/3 of this circle. So the area of our sector is going to be 1/3 of the area of the overall triangle, which was 100 squared pi. And then once again, it is just a cross multiply and solve situation. 360x equals 100 times 120. Okay, so 12,000 pi. And then we're just going to divide that out. 12,000 divided by 360 equals, oh, I didn't do a divided by. Let's try that again. 12,000 divided by 360 equals 33.33. Okay, remember we can always convert that to a fraction, or we can use the decimal value. Okay, so we have 100 thirds pi. Okay, so remember, if you're dealing with a sector, you always are going to have that pi value as a part of your answer. So our answer here is 100 times the square root of 3 minus 100 pi over 3. Okay, so those are our toughest problems that we have, but if you use ratios and work through on some of our common skills, we can definitely work through those and have some success with them. Thank you and have a good day.